Hey guys, my name is Omar. I'm a TA for machine architecture, and I'm gonna explain to you guys how to really use the debugger and how to basically run and think about solving part two, which is the puzzle box, but in assembly, right? I tried to do this earlier, and it took me 30 minutes, so I'm gonna try to be a bit faster. Yeah. So also, if you want to use the debugger for part one, feel free to do so, and it's probably going to be very helpful. But I'm not going to go through that because one, it's very easy and very short, and I don't want to re-explain this again. It's very easy to do it, and it's very well explained by the professor in the instructions. So if you just go to the instructions and you go to fucking where is it? Debugging your assembly code. It's literally just like run GDB btest and then enable the uh, layouts, which I'll do anyways, and you can debug part one, which is very helpful. So please do, especially if you're going to office hours. I'm gonna show you guys how to very quick, very quickly download the bombs. Please download the bombs once, and I'll show you guys how you might download it twice. Please download them once. If you download them twice, you might detonate like multiple bombs, and it's gonna cause issues with grading, and you're gonna lose marks. So what you want to do to download the bombs is that okay? Actually, let me just prove this to you guys so you don't doubt me. If you go to these links, boom, you can't access them. Boohoo, it sucks. You have to go through Vol UMN. Click on the first link. Uh, Go to connect to Vol. Click on that. Write your username. I'm just showing you guys this. Nobody comes to office hours asking these types of questions. And you do one, you'll get a duo push notification there. You get in here, and obviously I had a previous session, but let's delete this, or let's just launch another one. Fuck it. So you'll click on launch session. You're not gonna have this blue one over here. You click on launch session. You click on whatever the fuck any of these launch, and it's gonna open Vol. And then once you're in Vol, you want to open up the web browser, and when this pops up, just cancel it. Just ignore this. It might pop up multiple times. Come on, Vol, please, man. Please, I want to sleep. Let me browse the web, dog. Oh my god, I hate Vol. Maybe if I click slowly. Great. What do I, let's refresh. Bro, I swear to God. Okay, well, fuck that session. Let's go to this session. Anyways, as you obviously see, Vol sucks, and too bad you have to use it. So again, you want to click on the internet. Is it gonna let me? No, of course not. It's not gonna let me. Wait. Yes. With this, you just click cancel. Click cancel again. Just keep clicking cancel until the Google Chrome pops up, and then you want to go to Canvas and take a look at all my classes. Yeah. Go to Machine Arc. This doesn't show me the time, so I never know how long I've been recording. But go to fuck this project 3. Click on project 3, go down to the links, and then you can actually click on these. And here, please only write your X500, don't write your email. Click submit. You might not see the download because they don't no longer pop up at the bottom of Chrome. The download will automatically just be in downloads. As you can see, I obviously downloaded this earlier. So now you have the download, right? But also, if you just want to look at the scoreboards to see which ones you've passed, if you've detonated a bomb, Here you go. uh yeah, there it is. And as you can see, I've detonated a bomb a couple of times because I've been testing this, but I'll show you how not to do that. So yeah, you click on the download link, it'll be here in your zip. And then now once you've downloaded it on Vol, the nice thing actually is that like you could just move it to your desktop and then move it to whatever folder you have on your SSH machine or your lab machine. So like all these folders are also in my SSH. So I just moved it into my TA folder. Come on. Okay, my TA folder, and I moved it into project 3, and then here it is, right? I just moved it from my desktop to over here, and now it's in my SSH. So let's close this. We don't care about this anymore. Boom. Here, let me just. And now it's in my Wowie Wowie. You open your SSH, is going to be there. So this is your bomb. You're going to want to unzip it outside of Bitwise. Do not zip it inside of Bitwise. Please do not zip it inside of Bitwise. Zip it outside of Bitwise, but still inside of Project 3. So then you'll get a bomb file and your number. And you'll want to make the input.txt. That's a hint, kind of. You'll want to do a input.txt because that's going to be the input that we give to our debugger and our program bomb.c, right? So if you look at bomb.c, it actually kind of doesn't make too much sense. There's a main, nice, and then there's like these argument checks. Thank you, Professor Kobe. And then there's an initialized bomb, and then phase 1, phase 2, phase 3, phase 4. And what we're going to have to do is that we're going to have to run through this in assembly and then step into all of these phases to see what's going on so that we can pass all these fucking things. Right. So how do you run the GDB bomb? You literally just write GDB bomb. Also, make sure that you're in the right directory, please. Make sure that you're in the right directory. I'm in the bomb directory. That's where I'm supposed to be. You open up the debugger. First thing we want to do is set args to be, so we're setting our argument to be the input.txt file. Input.txt. Great. Now our argument is input.txt file. That is awesome. And now two other main things we want to actually see in assembly. So we'll do layout assembly, which is just layout asym. Now we're seeing assembly code, which is just this program, but in assembly. And then we also want to see our registers. So you do a layout regs, and that's how you get your registers. We'll see them when we start running. Now, if you run without setting breakpoints, you will explode bombs. You will explode bombs if you do not set breakpoints. You want to set breakpoints literally everywhere. And I'll show you how to do that right now. But also, exploding bombs is not a big deal. If you explode 600 bombs, you only lose 10 marks on the project. So it's not a big deal. Don't stress over it. Consider this a fun part, even though you'll hate yourself by the end of it. It's very easy to avoid exploding bombs, and I'll show you how. So now we have the two layouts, and we'll want to set a basic breakpoint on main. I already explained how to set breakpoints before. And what we want to do is that phase 1 is a function call, and that's how bombs explode. So we'll probably want to set, actually, I'll show you an example of a bomb exploding so you know what it looks like when it actually happens. So now we only have a breakpoint on main, and then let's run this. And things start looking goofy, right? Like, what the fuck is all of this crazy stuff that's happening? So these are all our Kali registers, and these are the representation in hex, right? So this is representation in hex, and then this are like memory addresses or random numbers in them, whatever is in them, right? Right now, it also tells you what line we're at, kind of in the program. So we're at the top of the page, but that's irrelevant to us. These first couple of lines are really irrelevant to us since we're giving the program an argument anyways. So we're not going to fall into any of these if statement cases. So yeah, this is just doing that. Irrelevant, 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 irrelevant. And now actually we're getting pretty relevant. So right now we're on the initialize bomb line, which as you can see clearly, it says initialize bomb. and also kind of the line number it's around. So if you go to initialize bomb, this just created all our bombs. And then synthetic pointer, whatever irrelevant for us, synthetic pointer, whatever irrelevant for us. And then control L to clean this thing up. We're kind of line 75 ish. Moving on. If I keep, see, I haven't set a breakpoint at phase one, so if I just keep doing this, right? Right now it's about to call phase one, right? If I click next, well, now if I click next, if I click next right now, it's gonna call phase one, and we're definitely gonna fail it because this is not the answer, guys. Okay, so here we go. Boom! Oh my God, we detonated the bomb. The bomb has exploded. Your structure is notified. You lose your job, right? So now you sadly rerun the program and you're crying. And now let's set a breakpoint at phase one. So not only are we able to step into phase one when we get to it, but we're also not going to instantly just detonate the bomb once we go over that line. And you can just set it by doing phase like that. Boom, confirms it. And just for the sake of time, I'm not going to keep doing using the next operation. If you click continue, it'll just take you to your next breakpoint. And now we're actually in the uh, phase one function, which is what we really care about. And now you can no longer see this in C, so you have to just fully rely on what's happening in here, right? I'll quickly explain some basic stuff in here. Right now we're on the phase one line. So the first line of phase one, we're subtracting uh, uh, 8 bytes from the stack pointer, which, as we discussed, you should understand why this is happening from the lab. This is because we're calling a function inside of this function. So shit like that. Okay, you should already know this. And after that, something very interesting is happening, right? We're loading, since it's parentheses, that means we're loading a memory address into RSI. And RSI, I remember correctly, right? If we look at this graph again, the graph very important. What is RSI? It is the second argument. It is the second. Holy shit! It is the Kali register for the second argument of a function, right? So what the fuck happened to RDI? Where did RDI go? Right? RDI is clearly not in here. You know what that means? That means that our input must be the RDI, right? Because otherwise, what the hell, right? And to confirm, I have trust issues. I don't know about you. I want to know for a fact that RDI has what I inputted uh, in it in the input.txt. So let's look at RDI over here, RDI, and then its representation in hex, and then this 938 blah blah blah. Obviously, well, not obviously, but kind of looks like a memory address, right? This is kind of the structure of a memory address. And in order to print stuff in assembly, instead of using the print like we would in C, you have to use the x dash s for string, x dash s d for decimal, and then h for hex, I believe. Where are these commands, Omar? They are in the GDB guide on Canvas, and they are very explicitly stated right here. It's perfect. Please always have this handy on you and when you're going to office hours. So we know we inputted a string, so it's obviously going to be a string, and we're asking to print the memory address, so you have to put a dollar sign, and it's memory address RDI, memory address RDI. We input, oh my God, it's HHH. I am a god at computing. We are correct. We are putting stuff into RDI. So RDI is what we put into it. But what is an RSI? What is an RSI? Who knows? Who knows? Is it? Uh, and if we look at RSI over here, it looks like one because we haven't ran the line. Let's actually just run the line. So now, as you can see, I was correct that we're moving a memory address into RSI, which means there's something of value inside of RSI, right? It could be a string. Okay, it's obviously going to be a string, but I'm not going to print it because that's the answer. Uh, It could be a string. It could be a int. A decimal number. So let's try that. Obviously, this is not what you should be caring about, but I'm just showing you an example. Right, 87. Who gives a shit? Anyways, so okay, we know that RDI has our input. RSI has some other value string. Okay, it's a string that has a string in it. And we know this because just from following the logic. So right now, after we moved from that line, we're now in this other line that's calling another function called strings not equal. Now, in this first part, you obviously know what's happening, right? It's strings not equal, so it's comparing the two strings to check if they're equal or not. But you don't know if they're equal. Is it asking for a length? Is it asking for the actual letters? What is it asking for? And maybe this function, the professor was like, I'm gonna call it barbecue. You don't know what the fuck is going on in there. So you want to know what's going on in there. And if you do, you want to do the SI instruction, which is this step into, but you add the I because it's assembly. And then boom, it will take you there and it will show you slowly. And we kind of know what's happening in here, especially if you did the lab. We're pushing these registers because they don't exist normally. And then it's taking the length and then taking the length and then it's checking if they're equal or not, then it's popping them because that's what you have to do, and then it takes us back to the line. And then as you can see, test is testing the output of, I'm assuming, strings not equal. And then if you move on, jump to that line if they're not equal, and we did jump to that line, and that line is a bomb. If I click NI, it will explode. If I rerun, it won't explode. And that's how you kind of avoid bombs. You can also set a breakpoint here if you want to hurry this process up. And that's kind of how you do the first part, and also how you should be thinking and understanding that, like, okay, these are my registers. They might have memory addresses, they might have integers, they might have strings, they might have a memory address that contains a string, so I need to print it in that format in order to understand what's going on. That's the hint for this part. It's literally just that. And then the other parts get a little bit more complicated. You need to understand how stack works, how we allocate space for the stack, how the stack is used in general. And yeah, hopefully this helps you guys. And if you come to office hours, like, please do this. Like, do this, debug a little bit, run stuff, kind of understand what's going on, and then come to us with a valuable question. Uh, yeah, oh, it's not too bad. You'll get through it. I kind of liked this part of the project. And yeah, good night. It's 2:30 a.m. So I'm going to sleep. Goodbye. Uh, where is it? Where is stop sharing? Or, no. There we go.